Hey guys, this is Mr. Roberts. We are going to go over our Unit 5% review today. So let's get to it. First things first, we're going to look at our bell work. Okay, so here is your bell work. Let's look at number one. Number one says, are the following expressions equivalent? Well, you can... the easiest way to do this one is just to make one, either expand one of them or simplify one. So I'm going to expand this one and use distributive property. I'm going to go 6 times x is 6x, and 6 times 4 is 24. And would you look at that? Those have the same things, don't they? It's just flip-flopped. So are they still equivalent even though they're flip-flopped? Yeah, because this is a commutative property of addition. It doesn't matter if you flip-flop the expressions that are there. It doesn't change the value. So they are equivalent. The other way you could have done this problem, just kind of interesting to look at, is I could have put this through the cake method and went 24, 6x, and 6 can go into both of them, and this turns into 4, and this turns into x. And so you have 6 plus 4, or 4 plus x with the 6 on the outside. So you can see it turned into this. Again, the 4 and the x are flip-flopped, but because it's addition, it doesn't change the value, so they are equivalent. Okay, let's look at number 2. There is a classroom of 35 students. The ratio is 5 boys to 2 girls. How many boys are in the classroom? So this is a total right here. This 35, it isn't boys, it isn't girls, it's total students. So that lets me know that I can use a tape diagram if I want to. So we are comparing boys to girls. And we know that there's 5 boys, so I'm going to make this and go 1, 2, 3, 4, 5, and then this, 2 girls. Now, we know that this equals 35. Well, how many of those boxes are there? There's 7, so 35 divided by 7 is 5. So each of these is worth 5. And it wants to know how many boys are in the classroom, so 5 times 5, there are 25 boys. So that is one way to do that problem. The other way is you can set up a proportion, but just remember you need a total down here. So you can use the proportion, but that right there is probably the easiest and most obvious way to solve that problem. And again, it all stems on, it gave me a total. Let's take a look at number 3, use substitution to check. So when you're using substitution to check, well, the way that I think about substitution is a substitute teacher. So this is what the substitute, and they're going to come in and take the x's place so that this becomes true. So something plus 3 is 11. It's 8, right? So we have x equals 8. Now, there is an algebraic way to do this, and I'm going to just introduce it to you because we are going to start looking at this next week. So, first thing I do is I draw a railroad track at my equal sign. Now, what is the, you see where that x plus 3 is? Well, what is the inverse operation of adding 3? Well, subtracting 3. So that leaves the x by itself. You want that x right here to be by itself. So because we subtracted 3 here, we are going to subtract 3 here. And we get 8. So x equals 8. Substitution method is just to plug in numbers until it works out. You can use algebra to also solve a problem like that. All right, let's move on. All right, guys. The practice for this week, for this assignment, we're going to kind of do it as a class, or I have a little fun activity for you to do as tables. So we are just going to do 2 questions on this review, and then the rest of it will be done in class. So let's take a look at number 2. So again, this is a review for the test that'll be tomorrow. So we are looking at a percentage. So we're going to go line equals line over 100. That says 220%. And the of is down here. Remember, it's is over of. You can also think part over whole. So we have of 20, and we don't have this. The rest of this can be done on your calculator. We're going to pull out the calculator, go 220 times 20, and we get 4,400. And we're going to divide that by 100. And you get 44. So we have 44 out of 20 is 220%. So yeah, that makes sense because it's over 100%. If it was 100% of 20, it would be 20, but since it's 120%, 44 makes sense. All right, let's go down and look at one of the word problems. We are going to look at number 7. Your family eats at Chili's, and the bill comes out to $52. How much would a 20% tip be? So we're trying to find 20% of 52. So we are going to start out with line equals line over 100. It gives us the 20. It goes here. We have the part and the whole. So I think that this $52 is the whole amount of the bill. So I'm going to put it right here, $52. And I want to know what the percent of this is. So I'm going to go 52.00 times 20, and I get 1,040. I'm going to write that down so I don't forget it. And then I'm going to divide by 100. Well, when I divide by 100, I move the decimal 2 places, so I get $10.40. So if I wanted to leave a 20% tip, and the bill was this, that's the tip that I would give, is $10.40. And that is pretty typical when you go to a restaurant, that you leave a tip and it's usually around 15, depending on how well the waiter or the waitress did. But 20% is pretty normal, pretty standard. All right, guys, I think you guys can handle the rest of these. I'm going to turn you loose. So good luck, and we will talk to you tomorrow.